Hello students, welcome in your classical mechanics class. In this lecture we will find out the equation of orbit in inverse square force field. The equation of orbit of a body moving under the effect of a force obeying inverse square law can be obtained from the differential equation of the orbit in central force. The differential equation was d square u upon d theta square plus u is equal to minus mu upon L square u square into f of u. This expression was derived in our previous lecture. You can go through the lecture. So where u was a variable which was u equal to 1 upon r. So that was discussed in the previous lecture. Since the gravitational force and electrostatic force between two opposite charges is inverse square force because it follows inverse square law, that is force is directly proportional to 1 upon r square. So if we consider F is directly proportional to minus k upon r, so that k is constant of proportionality. K is, in case of gravitational force, is g mm, and in case of electrostatic force it is 1 upon 4 pi epsilon naught q1 q2. q1 and q2 are charges, small m and capital M are the masses of the two bodies, and g and epsilon naught are the constants. You know very well in your junior classes what are these constants. So since we know r is 1 upon u or u equal to 1 upon r, so f equal to minus k u square. So we will modify equation 1 with the help of this. So it is d square u upon d theta square plus u is equal to minus mu upon L square u square, and f is minus k u square. So u square is cancelled, so it is d square u upon d theta square plus u is equal to minus mu upon L square into k. So this is the expression. So now, here it is plus. So we will rewrite it as d square u upon d theta square plus u minus mu k upon L square is equal to 0. Let it be equation number 3 and let it be equation number 2. Now we have to solve this expression, equation number 3. So to solve this equation or simplify, we consider x equal to u minus mu k upon L square. So we substitute this value as x. So here we have d square u upon d theta square. So we will also get the derivative of that expression, that is dx upon d theta. It is du upon d theta because it is a function of theta and this term is not a function of theta, and double derivative is d square x upon d theta square is d square u upon d theta square. So we will substitute these two values of x and d square x upon d theta square. In equation 3 we will get d square x upon d theta square. This term is x as we assume plus x is equal to 0. So this is a simple mathematical differential equation, d square x upon d theta square plus x equal to 0, and the general solution of this expression is x equal to a cos theta minus theta naught. Why I consider theta minus theta naught we will discuss later, but at present please consider it as x equal to cos theta minus theta naught. Now we know the value of x, so we will substitute this value and we will substitute the value of x, a cos theta minus theta naught is equal to u minus mu k upon L square. From here we can write as u equal to mu k upon L square plus a cos theta minus theta naught. So we can further rearrange it as we know u equal to 1 upon r. Mu k upon L square is common on right hand side, 1 plus L square A upon mu k cos theta minus theta naught. So this is expression number 5. Now this is the differential equation or equation of trajectory of the body, that is 1 upon r equal to mu k upon L square, 1 plus L square A upon mu k cos theta minus theta naught. So in order to investigate the nature of the trajectory of the body, we compare this expression number 5 with the equation of the general conic in plane polar coordinate system. And in your mathematics solid state geometry, you know the expression of general conic. The expression of general conic is 1 upon r is equal to 1 upon L. This L is the semi-lattice reactum, 1 plus E cos theta minus theta naught. This small e is eccentricity. This eccentricity is useful to find out, or it specify the trajectory of the conic, that is eccentricity of the conic. And from these two expressions 5 and 6, if we compare, we have this small l equal to L square upon mu k, and this small e eccentricity equal to L square A upon mu k. So I hope you remembered what is L. L is angular momentum vector, mu is reduced mass, k is the constant. So this constant, if you are talking about the gravitational force, then gmm, and in electrostatic it is 1 upon 4 pi epsilon naught q1 q2. So we have generalized it, and E is eccentricity, and but is this A is constant, we will find out, and mu is reduced mass, and k is again these two terms. So the exact shape of the trajectory, whether it is circular, parabolic, hyperbolic, whatever it is determined by the eccentricity. So the trajectory of the body depend upon E, which is a function of A. A is a constant, the angular momentum vector L, and the trajectory of body is hyperbolic if small e is greater than 1, and it is parabolic if small e is equal to 1. It is elliptical if small e is less than 1, and it is circular if small e is equal to 0. So many times students forget when it is hyperbolic, parabolic, elliptical or circular. So you can remember it. If E is greater than 1, E is high, hyperbolic. E equal to 1, it's like a rotation of parallel symbol, then parabolic. E is less than 1, obvious third option is elliptical, and E equal to 0, it's like circular. So you can remember in this way, E is higher than 1, hyperbolic, otherwise it's greater than. E equal to 1, so this symbol is the rotation of 90 degree of some parallel symbol, so it is parabolic. E is less than 1, so it is elliptical. E equal to 0, so it is like circular, so circular. So this is the way to remember. Otherwise you can learn in your mathematics classes how you can find out the nature of the path or the trajectory with the help of eccentricity in your solid state geometry. So this is all about the equation of orbit. For finally we have find out 1 upon r equal to mu k upon L square, 1 plus L square upon mu k cos theta minus theta. Now this expression phi is the equation of orbit in inverse square force field. Thank you for watching. In the next lecture we will talk about the turning point, which is very important. What is the turning point?